Welcome back to Max with RP. So we have been solving word problems involving maxima and minima. There are plenty of problems that you can solve for practice so that you understand the underlying content and the principle behind maxima and minima. So we are going to solve some more problems today. Okay, the first problem is the following. A cylinder is such that the sum of its height and the circumference of its base is 10 centimeter. So you have a cylinder. Let the dimensions be R and H respectively. Okay. What is given? The sum of its height, which is H, plus the circumference of its base, which is 2 pi r. As you know, in a cylinder, the base is a circle. So what is its circumference? 2 pi r. What is the height of the cylinder? H. This is given to be 10 centimeter. So this is given. Now with this 10 centimeter as a sum of H plus 2 pi r, it is possible to find infinitely many cylinders. But what we are going to do is we are going to find the one which has got maximum volume. So what is it that you need to maximize? The volume. To maximize volume. What is the volume of a cylinder? Pi r square H. Both R and H are variables. This is a constant. What is a constant? H plus 2 pi r is a constant. Now this is a function of two variables. So what we should do? We should express it as a function of a single variable. So I can write H is equal to 10 minus 2 pi r. So you can see V is a function of R and H. So I am going to write H as 10 minus 2 pi r using the given condition. So V is equal to pi r square into 10 minus 2 pi r. Or V is equal to 10 pi r square minus 2 pi square r cube. Pi into pi, pi square, r square into r cube. So this is the volume. Now it is expressed in terms of a single variable, r. So we have to differentiate with respect to r. So dV by dr is equal to 10 pi into 2r. Because 10 pi is a constant, differentiating r square you get 2r. Minus 2 pi square, which is a constant. Differentiating r cube, you get 3r square. To find the critical point, dV by dr is equal to 0. Okay. So, 10 pi into 2r is equal to 2 pi square into 3r square. Okay, so let me first get rid of 1 pi. So this will be gone, right? Then 2 gets cancelled. So I will have 10r equal to 3r square pi. I can cancel off r because r is a radius and it is not equal to, cannot be equal to 0. So 10 equal to 3r pi. Therefore, r equal to 10 by 3 pi. So, I've equated dV by dr to 0. So, 1 pi gets cancelled, right? And then 2 gets cancelled. And you are left with 10r equal to Having cancelled 2, you are left with 3r square pi, having cancelled 1 pi. So 10r is 3r square pi, or 10 equal to 3r pi, or r equal to 10 by 3 pi. So the claim is, when r equal to 10 by 3 pi, if the volume is maximum, it has to happen only at r equal to 10 pi. But are we right? How do we verify? We have to find the second derivative. So let us calculate the second derivative. So how do you calculate the second derivative? Which is the first derivative? This is the first derivative. So we have to differentiate this. So when I differentiate 10 pi, 20 pi is a constant accompanying r. So d square v by dr square will be equal to 20 pi, because 20 pi into r. So if I differentiate that, what will I get? 20 pi minus 6 pi square is a constant. When I differentiate r square, I will get 2r. 2 into 3, 6 pi square. If I differentiate r square, I will get 2r. This is 20 pi minus 12 pi square into 2 into 6, 12. 12 pi square into r. R is 10 by 3 pi. So I have 20 pi minus 40 pi, which is equal to minus 20 pi, which is less than 0. Therefore, V is maximum at r equal to 10 by 3 pi. When r equal to, the question is, what is the, find actually the maximum volume. So not only are we finding r and h, we have to find the maximum volume. What will be h? H will be 10 minus 2 pi into 10 by 3 pi. Because 2 pi r, for r I am substituting 10 by 3 pi. So pi gets cancelled. 10 minus 20 by 3 is h. This is, if I take LCM, I will get what? So h is equal to, if I take LCM, 3 is LCM. So 30 minus 20, 10. 10 by 3. So h is 10 by 3. R equal to 10 by 3 pi. So what is the maximum volume? Volume is what? Pi r square h. So volume will be, what is the maximum volume will be? Pi r square h, which is pi r square h, which is pi into r square is what? 100 by 9. R is this. So 100 by 9 pi square. Pi r square. H is what? 10 by 3. So you will get, this is what? 1000 pi by, this is 1000 pi, 27 pi square. So 1000 by 27 pi. So this is the value of the maximum, this is the maximum volume. So maximum volume occurs when r is 10 by 3 pi and h is 10 by 3, and I substituted in the formula for volume, you get maximum volume. So is it clear how we got the answer? Now find the dimensions of the rectangle of perimeter 0.36 meters, which will sweep out a volume as large as possible when revolved about one of its sides. Let us suppose we have a rectangle. If I have a rectangle like this, okay, if I sweep out like this, what will I get? I will generate a cylinder. So this is a rectangle. Take one of its sides and then sweep out like this. So what will you get? The figure that you get will be a cylinder. So this is the rectangle. What is the dimensions of the rectangle x and y? The perimeter, what is given? Perimeter equal to 0.36. What is the perimeter of a rectangle? The dimensions are x and y. So 2x plus 2y equal to 0.36. So x plus y equal to 0.18 or y is equal to 0.18 minus x. This is the relationship between x and y because the perimeter is given to be 0.36. Okay. Now we have to maximize the volume. So with this, perimeter, you can have infinitely many cylinders, but we want to find the one which has got maximum volume. So maximize the volume. What is the volume of a cylinder? Pi r square h, which is here pi into, this is the radius. The side, the width of the rectangle becomes a radius. So pi x square. Okay, the height of the rectangle becomes the height of the length of the rectangle becomes the height of the cylinder. So pi x square y. So volume is equal to pi into x square. Y is 0.8 minus x. This is further 0.18 pi x square minus pi x cube. This is what volume. Now dV by dx is equal to 0.18 pi into the derivative of x square is 2x minus pi into 3x square. I have differentiated this. What will I get? This is pi x square into 0.18 minus pi x cube. So when I differentiate this, 0.18 pi is a constant. So I have to differentiate only x square, which is 2x. Pi is a constant. If I differentiate minus x cube, I will get minus 3x square. To find the critical point, dV by dx must be equal to 0. So 0.18 pi into 2x is equal to 3x square pi. So your pi gets cancelled, right? So 0.18 into 2 will give you 0.36x equal to 3x square. So I can cancel off 1x. So 3x equal to 0.36 or x is equal to 0.12. So what is the value of x? X is 0.12. Now for claim is for this value of x, the volume is maximum. Okay, because this is the critical point. Critical point is happens at x equal to 0.12. So what is the thing that you have to do next? We have to verify the second derivative. What will be the second derivative? This is dV by dx. So d square v by dx square will be equal to, if I differentiate this, what will I get? 4x, if I differentiate, I get 4. So this is 0.36x. So if I differentiate, I will get 0.36 minus 3 pi into 2x. 3 pi is a constant. If I differentiate x square, I get 2x. This is 0.36 minus 6 pi into 0.12. This is 0.36 minus 0.72 pi. Definitely it is what? This is greater. So this will be what? This is greater, this will be less than 0. Therefore, V is maximum at x equal to 0.12. So when x is 0.12, so find the dimensions of the rectangle. So the dimensions are x is equal to 0.12. Y will be 0.18 minus 0.12, 0.06. So y will be 0.18 minus x, 0.18 minus 0.12, which is 0.06. So for these values of x and y, the volume is maximum. Next problem. Show that the semi-vertical angle of a cone of maximum volume and given slant height is given by these two figures. That is cos inverse 1 by root 3 and tan inverse root 2. So what do you mean by semi-vertical angle of a cone? So let us draw a cone. Let R and H be the height. Let R and H be the radius and height of the cone. The semi-vertical angle is this. We call it as theta. Okay. Now what is fixed? What is given? Read the question. Given slant height. Okay. So L is a constant. I always tell you first find which is a constant and which is a variable. So given L, given slant height, you can have several cones, but we want to find that cone which has got maximum volume. So R and H are variables. Okay. Now since we want to express everything in terms of a trigonometric function, so I am going to also understand, you must also understand tan theta is R by H, right? And cos theta will be H by L. Now, what is it that you have to maximize? Volume. So, maximize V equal to 1 by 3 pi R square H. Okay. Now, you know that I can write everything now in terms of theta. What is tan theta? Tan theta is R by H, opposite side by hypotenuse. Okay. And what is sin theta? Sin theta will be R by L. Okay. What will be cos theta? H by L. Okay. Now, I can write everything in terms of L. This is pi by 3. What is R square? R is L sin, R is what? L sin theta, and H is L cos theta. Okay. Now L is a constant. So pi by 3, R square will be L square sin square theta, H will be L cos theta. This is volume. So volume will be what? Pi by 3 L cube. Pi by 3 L cube sin square theta cos theta. Theta is a variable. Okay, L is a constant. H and R are variables, which means theta is a variable. So dV by d theta is equal to pi by 3 L cube sin square theta into derivative of cos theta is minus sin theta plus cos theta into derivative of sin theta is sin square theta is 2 sin theta cos theta. Sin square theta into derivative of cos theta, which is minus sin theta, plus cos theta into derivative of sin square theta is 2 sin theta cos theta. Now this is equal to 0 in order to find the critical point. So sin cube theta will be equal to 2 sin theta cos square theta. I can cancel off one sin theta because theta cannot be 0. So cancelling one sin theta, you will get sin square theta will be equal to 2 cos square theta, or tan square theta equal to 2, or tan theta equal to root 2. It can't be negative here, so we are writing tan theta as root 2. Okay, which means theta equal to tan inverse root 2. Theta, if tan theta is root 2, now what will be? What else? So we have proved this part. Now what about cos theta? Cos theta is h by L. Cos theta equal to h by L. Okay. Now, or theta equal to cos in. Okay. Now if tan theta is root 2, in a right angle triangle, if this is theta, if tan theta is root 2, then what will be cos theta? So you have to find this, right? This is opposite side by hypotenuse. So root 2 square is 2, 2 plus 1, 3. So cos theta will be 1 by 3. So if tan theta is root 2, cos theta is 1 by 3. So theta will be cos inverse, is it not 1 by 3? Root 2 square is 2 plus 1 equal to 3 square, which is, this will be, this is L. So L will be, L square is 3. So cos theta will be 1 by root 3. So theta will be cos inverse of 1 by root 3, which is what we wanted to prove. Tan theta is root 2, cos theta is 1 by root 3. Okay, if tan theta is root 2, automatically cos theta is 1 by root 3, which means theta is cos inverse of 1 by root 3. So I'm going to leave as homework for you to find d square v by d theta square. So for this, you have to just differentiate this and substitute tan theta as root 2, or cos theta is 1 by root 3. If cos theta is 1 by root 3, what will be sin theta? Sin theta will be what? Opposite side, root 2 by root, L is what? Root 3. So theta is also sin inverse root 2 by root 3. So substitute for sin theta, cos theta, tan theta, and check the sign of the second derivative. So finding the second derivative, I'm going to leave it as homework, as a task for you to complete. Okay. I hope you have understood how we have proved. We have used trigonometric function to prove. In my next video, the same problem, I will also prove it algebraically. Okay. Please go through this. Then we will see another method of doing the same problem in the next video. I hope you are all now getting the hang of how to solve word problems involving maxima minima. I hope you have understood you have developed a conceptual understanding of what is local maxima minima, absolute maxima minima, what is maximum value or minimum value, and how we are using calculus to solve real life problems. So if you find these videos useful, please share it with your friends. So until next time, it is goodbye. I hope you get enough time to practice lot of problems and you become very confident. Thank you.